are ready for the next speaker, who I have the pleasure to introduce, Bram Verhoef. He grows up in The Hague, but he moves to Belgium at the age of 6, and as a young student, he becomes fascinated by one thing, the human brain. And this fascination leads him to study psychology. But during psychology, he gets two more fascinations, mathematics and statistics, and the idea that intelligence perhaps can be modeled itself, or that intelligence itself can perhaps be modeled. So during a PhD in neuroscience, he simultaneously also completes a master's in statistics. Then he moves to America. He goes to Harvard. He works on computational neuroscience, using mathematics to model brain processes. At the University of Chicago, he takes his first courses in AI long before the launch of ChatGPT. And eventually, the combination of neuroscience, mathematics, AI brings him back to Europe. He goes to IMEC in Leuven, and he helps develop one of the first chips designed to accelerate AI processes in a far more energy-efficient way. Okay, then classic founder fashion. He takes a completely different turn. He starts a company in augmented reality until one phone call changes everything, because Fabrizio Del Mafio calls him and asks him, Bram, do you want to help build Axelera AI? And Axelera at the time is just an idea, but the ambition is there. And with people from IMEC, IBM, ETAs, Bitfury, and others, they start building, and they begin building what would turn into one of Europe's largest or fastest growing AI hardware companies. And today, Axelera has grown into nearly 300 employees worldwide, has raised 440 million euros. And this afternoon, Bram is here to talk about just that, how Europe can stop being afraid of taking technological leadership into its own hands. Please welcome Bram Verhoef.
Thank you very much for that kind introduction. I would like to start with a question to you. Who knows what this is? You. Yes, exactly. These are the 3 rules of robotics from Isaac Asimov. And you could basically see those as a precursor of what is currently, these days, a system prompt. And a system prompt are basically a set of instructions that model developers, think about large language model developers, they basically give to the model to make sure that it behaves as it's intended to behave. So, for example, making sure that it's not swearing, that it's avoiding certain topics, and basically some guardrails that are set for the model. And this was really one of the first system prompts that were out there, specifically then for robotics. Now, a couple of years after Asimov stated these 3 laws, he actually came up with, a new law. That went too fast. Now you know already. So this zeroth law was actually a law that was superseding all other laws. And it goes like a robot may not harm humanity or by inaction allow humanity to come to harm. The most important law for him, but it also says something, and here, if you just change the word humanity by, for example, Chinese people, this suddenly becomes a matter of sovereignty. And this just shows how easy it is in these models to bias a model in a certain direction so that it's actually beneficial for a particular nation, for example. And this can be, of course, for any, this is a politically relevant one, but it can be any nation that I'm stating here. So, given that we are very dependent on language models coming from the other countries, think about ChatGPT, Claude, but also in China, DeepSeek, we have the Qwen models. We are kind of vulnerable here, and we should really keep this in mind. Now, I have one other question for you. Who knows what this is? TSMC, great. This is the R&D center of TSMC. Now, I'm sure that most of you know what TSMC is, but just to get everyone on the same page, TSMC is the largest chip manufacturer in the world, especially when it comes to the most advanced nodes that are used for AI chips. About 87% of these advanced nodes, they are coming from TSMC. The thing is, if something happens to TSMC, we are in big troubles, and especially here in Europe. The reason is many advanced nodes, all the AI are coming from there, but also in Europe, we don't have a real alternative for it, especially inside Europe. Of course, there's Samsung, there's Intel, so there are some alternatives out there. But from the moment something happens with TSMC, everyone will want to have that chip supply, and especially as sovereignty will come into play so that their own countries will get supply first. Now, so also here something, chip manufacturing is something that we should really think about, and Europe is doing this. Now, the third thing I would like to show you is this one over here, which is one of the latest NVIDIA servers. And it also shows once again how dependent we are from foreign AI systems in this case. Because when all these AI factories and all these data centers that are currently being built, they all, for the large part, they really depend on these NVIDIA GPUs, like Bernardo also mentioned, but the whole servers actually are really coming from NVIDIA. So both in terms of models, but also chips, manufacturing, and in terms of AI systems, we are dependent on other countries. And this is something that we should think about and formulate a strategy about. Now, when it comes to sovereignty, I would like to mention three important verticals where sovereignty really matters. Now, the first one is the most, oops, it goes, oh, okay, anyway. This is, the first one is about defense, the most obvious one, of course. And definitely since the war in Ukraine, it has become very important, this drone warfare. These are crucial these days, and the amount of autonomy of these drones is rapidly increasing. So also here, these drones can be used for surveillance, can be used for, think about offensive application, but also, for example, for defensive applications as well. Think about interceptor drones. These are drones that attack other drones and prevent the offensive drones from attacking you. So this is becoming very important, and AI inside these drones as well. Now, the other vertical that is very important is robotics. And here robotics is interpreted in a broad sense. It's robotics both in industrial applications, but also in automotive applications, which is particularly important for the EU, of course, with all the car manufacturers. And then also more recently, and also towards the future, the humanoids that are coming into play. And robotics is so important because not only right now already, it's very important for our economy, but definitely towards the future, this is going to be the case. These robotics are more and more, they will take over labor from humans. And we have to make sure that we are ready in the right position, that we have control over the full supply chain of the robotics. Now, the last vertical that I would like to mention is the data centers. These data centers, they are now being fabricated in large quantities, incredibly important. And although initially, they were very important for training of the models. What we're now seeing is that more and more these data centers are crucial for the inference of the models, so for serving of these models for a wide audience. And every day, there are billions of requests towards these language models that we're all using. And just the ability to serve all those requests is a very tricky thing, and you need a lot of compute for that. So, these are three verticals that we should take into account, very important for sovereignty. But interestingly, these verticals, they have very different requirements. So if you look at, for example, the cost spectrum, on the left side here with the drones, we have these one-way drones. These are these interceptor drones. You fire them off, they hit something, and it's basically done. So it's only economical if the costs are very low. Now, if you then go to the right side towards a data center, there you need to be able to serve a lot of customers. There's a pure and good monetization model that they're still optimizing, but it's there. So costs are less important there. And that comes also with the second spectrum that I would like to show, and that's performance. So on the drone side, performance is less important because the application is a little bit simpler. Basically, what these drones need to do, they need to detect some objects and follow it, and that's it. And that can be done with relatively simple AI models. And of course, these drones are becoming more and more autonomous, but that's towards the future. On the right side, on the data center side, you need to serve all those requests with the most advanced models. So here suddenly the performance is becoming crucial, and there you really need the top AI chips that are out there. And the final spectrum that I would like to mention here is the energy spectrum. So on the drone side, we have usually battery-powered drones. So in this case, of course, the AI chip cannot consume too much energy. Otherwise, it's just draining the battery, and the action ratios will be much lower. On the right side, people are now building a nuclear power plant just to serve those data centers. So in this case, energy is much less much less important, although it definitely still is, of course. So we should, as in Europe, in terms of European sovereignty, we should definitely take all those spectrum into account, both in terms of cost, performance, and also energy efficiency. And that is something that when we started Axelera AI, we definitely had in mind. We started Axelera with a relatively small group of people. Currently, like Irene mentioned, we are 300 across the globe. We're very proud of our people. We have top people on board, crucial element. We also have great investors. We raised 450 million in total. And what we have done is we built up an AI platform. And that platform consists of both the hardware and the software. The hardware is centered around the chip that we have developed, and we have actually developed multiple chips right now. And then the software allows you to easily deploy models on our hardware. Now, the chips is just this one thing that we sell, but we also sell complete cards. Think about M.2 modules that you can use in embedded applications, PCIe cards to replace GPUs. We also have single board computers to replace NVIDIA Jetsons, for example. And we have full stack AI systems together with our partners, Dell, Lenovo, Advantech, and so on. And on top of that, we have the open source SDK. Now, and if we compare now our solution to those of our competitors out there, and of course, these are mostly foreign competitors, NVIDIA, but also players in like South Korea and so forth, we see that we are very competitive, actually, in terms of both performance, energy efficiency, and in also the cost. So this really shows that we can do this in Europe. Earlier on, there was a gentleman saying that we cannot really compete here on the hardware level. I think we really can. And actually, we have now proven this with over 500 customers. And the reason why we can be so good in terms of energy efficiency and cost and in power and in performance is because we have developed our own technology. And that technology is different from what is in a typical compute infrastructure. If you see like a typical computer, you have your processor, you have your memory, and each time you want to do some processing, you fetch from the memory into your processor, you compute a bit, and you write it back. Now that transportation between memory and processor, that takes time, that takes energy, and actually makes the chip larger, so more costly. So what we have done is we brought the memory and the processing together. So that we could save in terms of time, energy, and make a smaller chip so that it is cheaper. So that is what we did. And now I want to go back in terms of those three verticals that I showed you earlier, with the different requirements that were presented there. On the one side, we had the drones, then we had robotics, and then we had the data centers. And the current chip that we have on the market is the Metis chip. We name our chips according to the moons of Jupiter, so that's where the names come from. And this Metis chip is very performant, energy efficient, but also cost effective, and is really geared towards like computer vision applications, smart cameras, retail, surveillance, security applications, also drones for sure. And in the next months, we will actually bring our next chip to the market, which is the Europa chip. And it is much more geared towards generative AI and just this robotics that I mentioned before. And we are already working on the next generation of our chip, which is the Titania chip, and is much more geared toward data center performance. So here we try to span the whole spectrum that I mentioned before. But of course, it's not only the chip that we require. We need to come up with a full end-to-end AI stack. And here it means that we need to have first also EU models. And we have some good developers inside Europe. Think about Mistral. I just learned from Rolf that he's also developing modeling, so Datacation is also very good in terms of model development. And from the models you go to the chips. I mentioned it before, we have also Euclid. Then from the chips you need your coprocessors. There we have NXP, we have ST microelectronics. From those you need to go to like cards and servers. And actually here in Eindhoven we have ProDrive Technologies. And from that we want to have a full infrastructure for servers. So we need to have energy, cooling, and networking in place. And actually in Europe we have also a lot of those companies available. So basically, within Europe, we have the capabilities to build up an end-to-end stack. And Europe is actually promoting this. We have the CHIPS Act that is really looking at chip technology, but also fabrication. We have the Euro HPC joint undertaking that is looking at AI factories that are being built up. And then we have the like overarching strategy, the EU Continent Action Plan as well. So Europe is not sitting still, they're pushing, and I think that's a really good idea. So in sum, we have seen that there are different verticals with different needs out there, and that we actually have all the ingredients available to serve all those needs. And recently, Jensen Huang, the CEO of NVIDIA, he was at the graduation ceremony of Carnegie Mellon University. And he was talking about the importance of AI and mentioned there that AI is not something you walk to, but you have to run to. And I think we should do the same thing. Thank you.